Good morning. Today's topic is relation between solubility and solubility product. Okay. Solubility product is expressed as KSP. Okay. KSP is solubility product. Okay. Now, the solubility, or we can say molar solubility. Molar solubility, which is expressed as the concentration of the dissolved salt in a saturated solution. Okay, concentration of a dissolved salt in a saturated solution, or we can express as S. Okay, so KSP is solubility product and S is the molar solubility. Okay, if we take AgCl as an example. AgCl. In the case of AgCl, in a saturated solution, it ionizes as Ag plus and Cl minus, and these ions are in the ratio 1:1 concentration. Okay, 1 Ag plus and Cl minus. So, they are in the ratio 1:1 concentration, and S mole liter inverse is the solubility of these ions. Okay, let us take another example, BaSO4. BaSO4 also ionizes as Ba2 plus and SO4 2 minus. This is another example. These salts are of type AB type salts. Okay, AB type salts. These are ionizes in the ratio 1:1. Okay, so KSP of BaSO4, it's a constant, it is 1.1 into 10 raised to minus 10. Okay, now the concentration of this ion, this is equal to the concentration of these ions, concentration of Ba2 plus and SO4 2 minus. Concentration of these ions will be equal to the molar solubility of BaSO4. Okay, so this can be represented as S. Each ion can be represented as S. So S into S, so S square. Okay. Now, we can find the molar solubility of this salt. How can we find? KSP known, S square is equal to 1.1 into 10 raised to minus 10. Okay, so S is equal to root of this. So, we can write 1.1 into 10 raised to minus 10 whole raised to 1 by 2. What is the root of 1.1 into 10 raised to minus 10? 1.05 into 10 raised to minus 5. Okay, like this we can find the solubility, molar solubility of the different salts. This is of type AB type. Okay, so here the relation is KSP is equal to S square. This is the relation. Like this, there are different types of salt. Next type is AB2 type, AB3 type, etc. Let us discuss one by one. Okay. Now second type, AB2 type. Example is PbCl2. PbCl2 ionizes as Pb2 plus and 2Cl minus. Okay. So KSP will be equal to concentration of Pb2 plus and Cl minus square. Okay. So here concentration of Pb2 plus is S into. For 1 Pb2 plus there are 2 Cl minus ions are present. So solubility 2S whole square. This is equal to 2S cube. Okay. This is the second type. Now, so 2 square is 4. Now, S cube is equal to KSP by 4. Okay. So, S is equal to KSP by 4 whole raised to 1 by 3 or cube root of KSP by 4. This is the second type of salt. Now third type, AB3 type. Example is FeOH thrice. Okay, FeOH thrice. FeOH thrice ionizes as Fe3 plus and 3OH minus. Okay, so what will be KSP? Solubility product is concentration of Fe3 plus and OH minus whole cube. Okay, now this concentration is S. So for each Fe3 plus there are 3 OH minus ions are present. So 3S whole cube. This is equal to 27S raised to 4. Or we can write S raised to 4 is equal to KSB by 27 and S is equal to 4th root of KSB by 27. Okay. This is the another type of salt. Like this there are different types of salt. We can discuss one more example. Now we can discuss one more example. Fourth one, zirconium phosphate. Okay, zirconium phosphate, that is zirconium is plus 4 whole cube, then phosphate PO4 3 minus 4 times. Okay, this is zirconium phosphate. Zirconium phosphate. In this case, now it ionizes as zirconium and phosphate ion. Zirconium ion 3 ions are present and phosphate ion 4 ions are present. So KSP will be equal to 3S whole cube and 4S whole raised to 4. Now this will be equal to 6912 S raised to 7. 3 plus 4, 7. S raised to 7. Now S raised to 7 equal KSP by 6912, or we can write S will be equal to 7th root. That is KSP by 6912 whole raised to 1 by 7. Like this, there are different types of salts which ionizes in different ways and we can find like this. Now, how can we write in general? In general, let us take the salt B. M ion is Mp plus X times. Okay, and X Q minus Y. Let this be the ion. Okay, now it ionizes as KSP will be equal to concentration of Mx P plus whole raised to X. Okay, and this will be X ion is XQ minus whole raised to Y. Like this it ionizes, and KSP will be, what will be KSP? The concentration of these two ions. This will be equal to concentration of this will be S. So XS whole raised to X, and here it will be Y times S. The concentration of this ion is S, so Y times S whole raised to Y. Okay, so this will be equal to X raised to X, then Y raised to Y, S raised to X plus Y, S raised to X plus Y. Okay, this will be the case. So how can we find solubility? KSP solubility product and S. This is the relation in general. So S raised to X plus Y is equal to KSP by X raised to X, Y raised to Y. Okay, X raised to X, Y raised to Y. Now what will be S? S will be equal to KSP by X raised to X, Y raised to Y whole raised to 1 by X plus Y. This is the solubility in general. If we substitute in this, we will get the same value. Okay, so instead of small x and y, 3 and 4, so 3 cube 4 cube into s raised to x plus y. S raised to x plus y is 4 plus 3 7, so 1 by 7, same like this. So in general we can write like this. Okay, now KSP is same as QSP. QSP is, we already discussed earlier, QSP is the reaction coefficient. Under this equilibrium conditions, QSP becomes same as KSP. Okay. Also, solubility and solubility products depends upon temperature. Depends upon temperature. That is, if at a particular temperature, KSP and solubility and solubility product will have the same relation, but if the temperature varies, the relation changes. Okay, like that is solubility and solubility product depends upon temperature. Solubility varies with temperature, also solubility product also varies with temperature. Now let us discuss one problem based on this. Now before discussing the problem, let us conclude different types of salts. Okay, first type is AB type. In such cases, the relation between KSP and S will be KSP equal S square. Examples are AgCl, PaSO4, CuS and PbSO4. Next type, AB2 type. We already discussed. In such a case, KSP will be equal to 4S cube. And examples are PbCl2, MgOH twice, then Ag2Cr O4. These are examples. Now the third type is AB3 type. In such a case, KSP will be equal to 27S raised to 4. And examples are FeOH thrice, AlOH thrice. These are examples. Like this, etc. There are different types of salts. Okay. Now, let us discuss one problem based on this. So, the problem is, solubility product of CaF2 is 1.715 into 10 raised to minus 10 at 298 Kelvin. Okay, calculates its solubility at this temperature. So at this temperature, solubility is known. If the temperature varies, solubility product also changes. So ionization of this salt is Ca2 plus 2F minus. Okay, so KSP will be equal to S into 2S whole square, that is equal to 2S cube and 4S cube. 2 square S square, so 4S cube. So S cube will be equal to KSP by 4, or S is equal to KSP by 4 whole raised to 1 by 3. KSP is known, it's given in the problem, in the question. So this is 1.715 into 10 raised to minus 10 by 4 whole raised to 1 by 3. Cube root of this value. Okay, so after calculation, we will get the value 3.5 into 10 raised to minus 4. What is the unit of solubility? Mole liter inverse. Okay, this will be the answer. Like this, we can find solubility or molar solubility of a particular salt if solubility product is known. It's a constant value. So if it is known, we can calculate the solubility.